In this video, we are going to go over the triangle proportionality theorem and its converse. The triangle proportionality theorem says that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides those sides into proportional lengths. So let's draw the line that is parallel to one side of the triangle. That's going to be this line, x, y. xy is going to be parallel to AC. And it intersects one side AB and the other side BC. Since those conditions are met, then it divides those sides into proportional lengths. That means that AX over XB, AX over XB is going to be equal to CY over YB. Let's look at the converse of this. The converse of the triangle proportionality theorem, T43 in our case, says that if a line intersects and divides two sides of a triangle into proportional lengths, so that's saying that I have again a line XY that intersects AB and it also intersects CB, and we already are given that the lengths are proportional. So AX over XB is equal to CY over YB. That is what's given. That is the if statement. Then the line is parallel to the third side. So if this is true, then XY is parallel to AC. Let's go ahead and prove T43. Like with all proofs, we're going to start with our given. We're given that X intersects AB, Y intersects CB, and the segments that they create are proportional. AX over XB is equal to CY over YB. Our next step is manipulating this equation. And we're just going to add 1 to the left, and if we add 1 to the left, we also have to add 1 to the right. But there's a specific value 1 that we're going to add. The one we are going to add is created from the denominator on each side. XB over XB is equal to 1. YB over YB is also equal to 1. Having the same denominator will allow us to add the numerators. So in step 3, we simplified and added the numerators together. Let's look at what these numerators are. XB plus AX. XB plus AX is actually this full segment AB, and that's by the segment addition postulate. And over here we have CY plus YB, and that's this whole segment, or the whole side of the triangle, CB. And again, that's by the segment addition postulate. The segment addition postulate was P8. So now we can have that AB over XB is equal to CB over YB. We also know that this angle B is congruent to itself because of the reflexive property. So now look what we have based on step 4 and step 5. we have that AB over XB and CB over YB are equivalent, so they're proportional. And if you look, each of those segments is a side of a separate triangle. And angle B is in each of those triangles. So we can use side angle side to say that triangle ABC is similar to triangle XBY. And since triangle ABC is similar to triangle XBY by the side angle side similarity theorem, we're going to have that the angles within those triangles are congruent by the definition of similar polygons. So we can say that this angle A is congruent to this angle X. So by the definition of similar polygons, angle X is congruent to angle A. And we can see that AB is a transversal of XY and AC, and the corresponding angles are congruent. So we're going to be able to use the converse of the corresponding angles postulate, which was P13, to say that segment XY is parallel to segment AC. And that is what we needed to prove. Given that a segment divides two sides of a triangle into proportional lengths, then that line is parallel to the third side. Now we're going to go over a corollary that's related to this proportionality theorem. C5 says that if three or more parallel lines intersect two transversals, then they divide the transversals proportionally. So here I have three parallel lines. And these three parallel lines intersect two transversals. Because of that, then they divide the transversals proportionally. So if I was to label this A, B, C, D, E, from this corollary, I could say that AC over CE was equal to BD over DF. Also, that AE over BF was equal to CE over DF. And I could say that AE over CE was equal to BF over DF.